Today we are going to explore primitive data types and write our first variables. But before we dive in, it's important to stick to a few conventions. Throughout this video, and ideally in your own code, I recommend using camel case for naming your variables. That means the first word starts with a lowercase letter, like in this example, and each new word after that starts with a capital letter, like this one. Don't forget that and keep your code clean and readable because this is super important. Alright, let's look at some data types. What are data types? Data types define what kind of data a variable can hold. This is essential in Java because it's a strongly typed language, which means you must declare the type of every variable you use. This helps prevent bugs and makes your code more predictable and easier to understand. Java has 8 primitive data types, and these are built into the language for efficiency. Let's go through them quickly. Boolean. This one is super simple. It can only be true or false. It's useful for conditions, toggles, and anything binary, but we get to this later. And then we got byte, short, int, and long. These all represent whole numbers, integers, but they differ in size and range. You can see this right here. Byte is the smallest with the range from minus 128 to 127. Then short is a bit bigger, and int is the most commonly used. And then we got long for really big numbers. The reason we have multiple types for whole numbers is to optimize memory usage. If you only need a small range of numbers, maybe for printing the age or something, using a byte instead of an int can save space, especially in large programs or on devices with limited memory. And then we got float and double. These are for decimal numbers. Float uses 4 bytes and is less precise, and double uses 8 bytes and is more precise. So when in doubt, just go with double. And the last one is char. This holds a single character like A, B, or C. Chars are written with single quotes. And finally we got string. This is used for text like hello world, but a string is not a primitive data type in Java, it's actually an object. And we'll dive deeper into strings in future videos. Cool, now you might be wondering, how do I actually create a variable like an int? Let's jump into IntelliJ and take a look. As you can see, I still have the program open from the last section. I'm going to delete that example, and before we dive into variables, I want to make sure you guys understand the basic arithmetic operations. In Java, we can not only print strings, as shown in the last video, but also print the result of arithmetic operations like addition, subtraction, multiplication, and division. For example, if we divide 30 by 5, we get 6. As expected. But what if we divide 3 by 5? You might expect the result to be 0.6, right? But in Java, it prints 0. Why? The answer is data types. When both numbers are integers, Java performs integer division, meaning it just cuts off everything after the decimal point. So 3 divided by 5 equals 0 because Java ignores the decimal part unless at least one of the numbers is a decimal. This is a great example of why it's important to know what data types you're working with. It helps you to avoid unexpected results. Now let's get back to our example. We want to multiply 3 and 5 and store the result in a variable. I'm going to create a comment in the code for documentation. To create a variable, we need to first declare it and assign a value to it. Declaration is when you tell Java the name and the type of your variable, and assignment is when you give that variable a value. After the declaration, which includes the data type followed by a variable name of your choice, we can assign a value to that variable using the equal sign, like this. And of course, you can reassign a new value to the same variable later using the same syntax. Let's assign the result of our multiplication in it and use that variable. The declaration is only needed once, right at the beginning. After that, you can change the value as often as you like, but the type stays the same. Now let's assign the result of our multiplication 3 times 5 to our variable and use it. Whenever we refer to result, our variable, Java will use the value stored in that variable. So when I write system.out.println result, the output is 50, and that's because we stored that in result. Note, if you wanted to print a text or string result, it would be in quote marks. Variables work without them. In this example, I used integer for the data type for my variable because 3 and 5 are both ints. We could also use long, but I just wanted to stay with the most common used. Now, there's a shorter way to declare and assign a value to it in one line, and you do it exactly like this. What's important is that the variable must be declared before you assign a value to it or try to use it. If you skip that step, Java won't be happy and you'll get an error. How we read these called exceptions we'll learn later. And also the variable needs to be initialized before you print it, as you can see. To initialize just means assigning the first value to a variable. If there is no value stored in the variable, what's it supposed to print? Now let's store the result of 3 divided by 5 in it and print that. As mentioned earlier, the result is 0 because 3 and 5 are integers. To get the actual result, which is 0.6, we need to use a data type for decimal numbers instead for whole numbers. I'm going with float. But here's the thing, if we just write 3 divided by 5, the result is still going to be 0.0, even though it's a float data type. That's because the division is happening between the two integers before it's stored. To fix that, we need to convert at least one of the numbers to a float before the operation. You can do that by adding an f after the number, like 3f or 3.0f. And voila, our result isn't 0 anymore. Now let's change the data type of our variable named result to boolean. Why is IntelliJ warning us with a red underline? That's because a boolean can only be true or false, and it doesn't make sense to assign a number to a boolean variable. So let's change the value to true, for example, and print it. If we wanted to invert the boolean value to get the opposite of what's stored, we just type an exclamation mark before the variable name. So instead of true, the output would be false, and the output would be true if result was false. Now let's get back to numbers. Let's create a variable a with the value 12 and a variable b with the value 5 and print a plus b. We could also create a third variable c and do some calculations using a, b, and c. Now let's talk about strings. As mentioned earlier, strings are not primitive data types, they're actually objects. But don't worry, we'll dive deeper into what objects are later. For now, just remember that objects can do more and usually start with a capital letter, like string. You might have noticed that all primitive data types like int are written in lowercase, but string is capitalized. Let's create a string called name with your name in it and print it. You can also concatenate strings using the plus symbol. Just make sure the variable name is outside the quotation marks. Now the output looks pretty good, but don't forget to add a space before the variable when concatenating, otherwise the result will look squished together. Let's make it a bit more interesting by adding our age. Now you might be wondering, how can I mix integers and strings like this? Well, keep in mind that most things can be converted into strings automatically, and Java has some special conversion rules. We'll cover that more in a separate video. For the final topic, I want to make sure you guys understand what programmers mean by overflow. At the beginning, I mentioned that each data type has its own range. Let's take int as example. You can find the maximum value of an integer by typing integer.max_value. Now, what happens if we add 1 to that value? That's called an overflow because instead of getting a higher number, we wrap around to the minimum value an int can store. We basically overflow and roll back to the bottom. And the same thing happens in reverse. If you subtract 1 from the minimum value, it wraps back to the maximum. I suggest you to experiment a bit with these concepts until you feel secure. To wrap things up, I show you some examples of how to declare and initialize each primitive data type. Just experiment with them a bit and write your own program. If you have any questions or if this tutorial wasn't detailed enough, feel free to leave a feedback in the comments. I'm always open to improving, and super important to keep us motivated, don't forget to subscribe.